back to Adva Optical Networking's launch of the FSP150EGX product. If you're still with us, that means you want to hear more, and I'm going to walk you through all the unique features and functions of the EGX product.
So there you have it, the FSP150EGX. We've already covered this slide, so let's dig a little deeper. As already mentioned, the EGX is a 10U high chassis, less than 300 millimeters deep. There are 24 single-width traffic slots. The EGX has a centralized switch fabric of 140 gigabits per second. Also redundant with dedicated slots are the shelf controllers and system timing units. There are dual power supplies, 3 modular fan trays, as well as dedicated slots for system timing interfaces and alarms and management interfaces. Looking at the 24 single-width traffic slots, the EGX can support a max of 120 gigabit Ethernet ports. Let's look at this line card. The GE10S is 2 slots wide with 10 ports each. Now these 10 ports are SFP cages that can hold a 100 1000 base X SFP or also 10 100 1000 base T copper SFPs. Each port supports synchronous Ethernet, hardware time stamping with nanosecond accuracy, as well as jumbo frames up to 9600 bytes. The 10 gigabit Ethernet card is the XG1X. It is 1 slot wide, reuses FSP3000 optics XFP form factor, and is software configurable to support either LAN or WAN-Fi. They're also synchronous Ethernet with hardware-tied stamping with nanosecond accuracy, and also support jumbo frames up to 9600 bytes. For those customers wanting copper ports or used to RJ45s, on the roadmap is a 10 by 10 100 1000 base T card, as well as a quad 10 gigabit Ethernet line card. Legacy support is important in any edge gateway product. Let's face it, there's still a lot of E1 T1s out there making money for carriers. The EGX supports pseudowire emulation edge to edge as a gateway for E1 T1 handoff. The card is single width, supports 4 STM1 OC3 channelized or 1+1 STM4 OC12 channelized, SAT-top encapsulation, MPLS label for pseudowire multiplexing, as well as 802.1Q as a network header. The diagram below depicts one such application. The EGX also supports Ethernet over TDM line cards. The Ethernet over PDH card is single slot wide, supporting 16 E1 T1 ports, GFP, VCAT, LCAS, or multi-link point-to-point protocol, as well as 8 virtual concat groups. The Ethernet over SDH card is single slot wide, supporting 4 STM1 OC3 channelized, 2 STM4 OC12 channelized, GFP, VCAT plus LCAS, and up to 84 virtual concat groups. Clock distribution is an important function of an edge gateway product, especially when used for applications such as mobile backhaul. Now notice I said distribution, not just clock input or clock output. The EGX can take any of its ports and make it a master or a slave. And if you remember earlier, I mentioned this system timing interface. That's a module that lets you take in timing in lots of different ways, because it doesn't do you much good if you have a clock and the product you're trying to distribute clock with won't accept that particular clock input. So let's look at some of the features here. The EGX supports synchronous Ethernet for frequency distribution. All traffic ports support synchronous Ethernet, the 1 gig and the 10 gig. It has SSM and ESMC processing according to ITU-T G.8264. There's automatic clock selection with up to 6 candidate clock inputs per G.781. There's embedded Ethernet equipment clock compliancy with ITU-T G.8262. The EGX also supports 1588, in this case IEEE 1588v2 for frequency and time of day distribution. There is a transparent clock mode as well as boundary and slave clock modes. That's important because seldom is one product the only thing in a clock chain. This lets the EGX work well with anything within that chain. As well as there's a mediation function between 1588 and Sync E. Sometimes the two will conflict with one another. The EGX solves that. There can be multiple clock domains, up to 5 independent clock domains running within the EGX, because as any port can be master or slave, this lets you divide up which ports are in which clock domain. And finally, again, I mentioned that shelf timing interface that lets you bring that clock in. There can be 2 E1 T1 bits in, 2 E1 T1 bits out. There's a 110 megahertz input output on a BNC, a 1 PPS I/O on a BNC, as well as 1 time of day input output on an RJ45. I love this slide because it shows the power of the EGX, especially when used in a clock distribution application. On the left here, we've got a GPS receiver feeding a 1588 Grand Master. Now that's the master. Any port on the EGX can be set to a slave. That then is feeding out other master clocks. And if you remember, I said the EGX can support up to 5 clock domains. Here, one of those clock domains is taking that input, making a master, and feeding slave devices later on in the network. But at the same time, at the shelf timing interface, we've got a primary reference clock coming in. That's another clock domain that is feeding other ports on the EGX that now become other masters, feeding slave devices downstream from it. But check out what's going on in the middle here. We're feeding both clock domains to that middle slave device there, to where we have PTP and Syncy available for that device. The EGX offers a wide range of protection and resilience options for the end user. The EGX supports 802.3 AD link aggregation, up to 8 ports per lag, and lag members can be on the same line card or on different line cards. Load balancing and active standby mode is supported with L2 hashing and VID hashing for load balancing. Link aggregation control protocol can be enabled or disabled per lag group. The EGX also supports 1+1 fast protection switching, where a protection group comprises 2 ports, a bridge on transmit, and a selector on receive. Ports in a protection group can be on the same card or on different cards. The EGX also supports Ethernet line protection switching, Ethernet ring protection switching, and the 3 flavors of spanning tree protocol: standard, rapid, and multiple. When dealing with Carrier Ethernet, you almost have to learn how to speak a new language. It's no longer about just the Ethernet itself, but rather the Ethernet service you enable the service provider or carrier to resell to their customers. And the FSP150EGX speaks Carrier Ethernet. Let's look at some of the services enabled by the EGX. You can have a point-to-point service, in this case an E-line, Ethernet private line, or an Ethernet virtual private line. You can have a multi-point to multi-point service, in this case an ELAN, or you can have a routed multi-point service, which would be an E-tree. And the EGX supports up to 2,000 service flows. The diagrams below demonstrate what some of these different offerings would look like in a Metro Ethernet network. With the EGX, any port can be used as a UNI or an NNI. With a UNI, the interface is facing the customer. With an NNI, the interface is facing the network. A point-to-point flow can be created between any 2 ports. There are no hardwired access in network ports. A point-to-multipoint and E-tree service can be created among any ports. Ports support service multiplexing as well as processing 802.1Q, Q&Q, and 802.1 AD frames. Let's pause for a moment and talk about flow points. If you remember, I said Carrier Ethernet is like speaking a different language. Well, flow points are the endpoints of a service flow. They're bidirectional objects, the tags are manipulated, and individual policers and shapers can be created on each of those flow points. Now that we understand flow points, it's important to understand the concept of port service types. Now, with port service types, you can have an all-to-one port-based service, or a service multiplexing VLAN-based service. With an all-to-one port-based service, you're VLAN unaware, and all frames received are mapped to a single service flow. Now you can push and pop the C tags and S tags in the ingress or egress direction. With the VLAN-based service, you're now VLAN aware and can map different VLANs to multiple service flows. Only the specified VLANs are accepted and unknown VLANs are dropped. You can swap VLAN IDs in the outer VLAN in the ingress and egress direction, as well as also push and pop the C and S tags. When it comes to VLANs, you can never have enough. The EGX supports 4,096 VLANs per port, not per box, and system-wide 16,000 VLANs are supported. Now, even that sometimes isn't enough. So the EGX supports customer-tagged and stacked VLANs, Q and Q, as well as has a configurable TP ID for Q and Q frames. In addition to that, the EGX supports provider bridge tagging, CNS tags. With 120 GIGI ports and over 16,000 VLAN IDs, there's a lot of traffic vying for the scheduler at any given time, and traffic management becomes paramount. The EGX supports tagged or untagged client frame policy, classification based upon 802.1p, 802.1q, as well as IPTOS and DSCP for both IPv4 and IPv6 packets. 3-color color marking and 8 class of service per MEF guidelines is supported with strict priority, weighted round-robin, tail drop, and red all supported. Finally, hierarchical queuing and shaping for multi-class of service flows with committed information rate and PIR supported. And finally, considering where an edge gateway sits in the network, OAM is crucial, and the FSP150 EGX supports a wide range of OAM protocols. The EGX supports Ethernet in the first mile OAM link management, active and passive discovery, connectivity fault management CFN, as well as Y.1731 performance monitoring. In addition to this, there are terminal and facility loopbacks on the port and VLAN level, as well as MEF-compliant Layer 2 control protocol disposition and link loss forwarding to signal local link and network path failures.
Whew, that was a lot. Thank you for staying with me and learning more about the FSP150 EGX product. If you'd like to learn even more, please visit our website at advaoptical.com. Thank you.
Wait, are we on?
Are both shelf-based products.
Wow, Jim, we've been taping for a week and you've had that same blue shirt on.
What's your point?
Ew.